So hello everyone, my name is Valeria Olivares. I'm a new postdoc at the University of Kentucky, and the poster that I'm showing here shows some preliminary results on the systematic observed for X-ray cavities in plant selected cluster using Chandler observations. So the main goal here is to study the connection between the intercluster medium cooling and the AGN feedback heating mechanism in this plant sample. But we also explore how the cluster weather might be potentially affecting the shape of the X-ray cavities. We also investigate the role of the AGN feedback on the gas condensation by looking at the correlation of the X-ray cavities and the presence of cold gas. In particular, we found one non-Cuckoo cluster with a fair amount of cold gas, which is very, very exciting. So if you want to know more details about this, please come to me and see my poster C14. So I'm also presenting a second poster. The main goal here is to study the origin of the cold gas in central group galaxies using beautiful MUSE observations and some archival data. So we know that the cold gas in cluster is formed from hot gas condensation, but in groups, this is clear as groups are a more diverse class. Galaxy mergers here are expected to be more common as well. So we look at the distribution and kinematics of the ionized gas here, as well as the stellar population of about 18 groups selected from the clock sample, as well as some other X-ray criteria condensation to unveil the origin of the cold gas in these groups. So if you're curious to know what triggered the condensation in galaxy groups, please come and check poster C13. Thank you.
All right, so the GASP survey has identified an overabundance of AGN among jellyfish galaxies. And to address this in theory, we look at the high-resolution cosmological simulation RomulusC. This is a zoom simulation on a 10 to the 14 solar mass cluster with great dynamic range. The particle masses are about 10 to the 5 solar masses. And so you're able to resolve things like ram pressure stripping in dwarf galaxies pretty well. And what we find is that indeed you get peaks of ram pressure activity coinciding with peaks of AGN. In these three examples on the left here, specific star formation rate is blue, black hole accretion rate is red, and the ram pressure is orange. And you can see that around these peaks of ram pressure, you also get a peak of AGN activity. And my favorite example is the last one, which is a galaxy that sticks around on an eccentric orbit for many gigayears. And every time it reaches pericenter, you see this little blip. So come find me at D1 if you want to learn more. Thank you.
Yes, so hi everyone, I'm Benjamin Vigneron, an MSc student at Université de Montréal. So the main objective of my research is to pursue the analysis of new high spectral resolution observations of the Filamentary Nebula surrounding NGC1275, so the BCG of the Perseus cluster. So previous low resolution observations of the Filamentary Nebula were performed by Dr. Marie-Lou Gendron-Marcellet and allowed us to retrieve the entire velocity structure. However, due to the low resolution, it wasn't possible to perform a velocity components analysis. Therefore, high resolution observations were needed and acquired in 2019 with CITEL, Fourier transform spectrometer installed at CFHT. However, due to the high resolution nature of the data, careful analysis will be needed. And to perform this analysis, we will use machine learning techniques. And we're also working on a neural network to create an adaptive mask for our data. So I'll be really glad to answer your questions about this. Thank you.
Hi, so I mainly do simulation work of AGN feedback in galaxy clusters, and since Julie and Benjamin talked about the filaments in clusters, I want to point to my work last year about how they form. And if you're interested, you can also check out this paper. So back to the poster. So this is our take on how effective AGNs are at launching outflows in cool core clusters, and we found that the ratio between outflow and black hole accretion should be around 200 to 500 in order for the observed cooling time profile of the hot intercluster medium to agree with observations in both Perseus and M87, the two systems we model. So if you're interested in how AGN feedback works in galaxy clusters, come talk to me. Thank you.
Hi everyone, I'm Jess. I'm a first year PhD student at the University of Kiel. I'm working with the VMC, which is a high resolution, high sensitivity near infrared survey covering the Magellanic clouds, but also many background galaxies. Since this is a complicated field with a lot of stellar contamination, I'm using machine learning to distinguish galaxies from stars and to determine cluster membership. From this and other, I didn't start my video. From this and other multi-wavelength data, we can learn about cluster environment and evolution. So if you're interested in this, I encourage you to come and see my poster. It's at slot A14 in the Gavatown. You can direct message me on Slack, and I look forward to any questions you have and having discussions.
Yes, hello everyone, Francois Mernier here. Yeah, so my poster is about chemical enrichment of large-scale structures, and specifically on one galaxy in the Fornax cluster, so GCF2021, which, as you can see, is undergoing important RAM pressure stripping here. But I hope to convince you that these results are very interesting for the chemical enrichment aspects of galaxies and clusters in general, actually. So basically, we made use of very deep XMM change draw observations of GCF2021 to derive metal abundances through the entire galaxy extent. When I say abundances, I mean not only iron, but also very interesting other elements such as magnesium and silicon. So one result I'm going to show you here is a chemical composition of the gas that is remarkably consistent with that of our own solar system and the average ICM in more galaxy clusters, though it's still different from the stellar abundances of the galaxy. Another result is a spatial distribution of iron and other elements with powerful consequences for the enrichment scenario. But I'm not going to reveal that here, so just feel free to see my poster and to talk to me. I'll be happy to discuss with you.
Hi, yeah, I'm Ben Floyd. I'm a PhD student at the University of Missouri, Kansas City, working with Dr. Mark Broadwin and Dr. Becky Canning. Mostly what we're looking at is the dependence of IR bright AGN activity with respect to the halo mass and redshifts in the SVD cluster surveys. Our IR bright AGN are primarily selected through IRAC 3.6 and 4.5 micron colors. And qualitatively, we can see in the image here that clusters with low mass tend to have a higher AGN richness along the line of sight. And then we are currently working on quantitatively modeling these with our trends. So drop by my poster and I'll feel free to ask questions.
Yeah, hi everyone, I'm Eunhee. I will talk about the large-scale structure dependence on star formation activity in galaxy clusters. Web-fitting model explains that star formation activity in galaxy clusters is determined by the presence of nearby large-scale structures. I wanted to check this model in Cosmos field that provides the most reliable redshift. Using the 74 galaxy clusters, I calculated the quiescent galaxy fraction in each galaxy cluster and the fringe of fringe fraction that measures the prevalence of the large-scale structure by the fringe of fringe algorithm. These two factors are tightly anti-correlated at redshift around 1, which might indicate the large-scale structure is the main reservoir of gas in star-forming galaxies to keep galaxy clusters fresh and extended in size. You can see more details on my poster B16. Thank you.
Okay, hi everyone. In this work, we investigate the stellar populations and the ionized gas of a sample of central spheroidal galaxies extracted from spider catalog in order to better constrain their star formation history and gas excitation mechanism. And we separate these galaxies in different regimes of halo and galaxy mass, and to characterize their stellar populations properties, we use the stellar population synthesis method with the starlight code, and the presence of ionized gas is identified by H-alpha emission lines. As you can see at the figure on the left, we analyze how mini-stellar age and metallicity, extinction, and equivalent width of H-alpha behaves as a function of these regimes of mass. And we show that the ionized gas is well described by a simple model that includes a combination of AGN feedback from central galaxy and the ICM gas cooling. So if you're interested or have any question, my poster is still on, and you are welcome to talk to me on Slack. Thank you.
The aim of this work is to study a possible relation between the properties of a member galaxy and the global dynamic state of a galaxy cluster. To study the property of a galaxy, we use a spectral synthesis code to classify galaxy in a diagnostic diagram. To access the ICM properties through the X-ray data analysis, we construct to the map. To quantify this to the map, we use a non-parametric classification, such as the asymmetry parameter, and calculated the Spearman correlation coefficient. A preliminary result from the more analysis showed that central galaxy of systems classified as relaxed are found in the line in the safe region. Most weight contain AGN. These results could be in the indication that the gas is fitting the central object. Thank you very much.
Everybody from the Black Sea. My work is connected with inner substructures in the galaxy clusters with richness 100 and more. Me and my PhD students, Sviatoslav Yemelyanov and Anton Serginova, suppose the peculiarities in galaxy distribution in clusters reflect the different ways of cluster evolution from open one without any peculiarities to compact, regular with city galaxy. On the left in the slide, these ways are shown. We have studied our dataset and detect different types of substructures, namely crosses, semi-crosses, short chains, compact chains, etc. We found also a filamentary type of alignment of galaxies in many cases and wall type of alignment of galaxies in single case. We found also interesting chain in one cluster. So more in the poster C16 and welcome your questions by email. Thank you.